Okay, so first we're gonna solve the homogeneous differential equation. So we just set it equal 0, yeah? And then in that case, the characteristic equation will be r squared plus 1 equals 0, which makes r equals plus or minus I, which makes the complementary solution for the homogeneous differential equation a sin x plus b sin x. You agree? So now we're going to do the non-homogeneous. The non-homogeneous. So we're going to differential equations. So we're going to take care of the right-hand side now. So this is y double prime plus y equals 4 sin x plus e to the x cosine x. So for y particular, you're going to assume a solution of the form. Now for sin x, you're going to get a sin x plus b cosine x, yeah, because the sine will get you a sine and a cosine. Okay, but here's the trick. If you look carefully, you notice that the sine and the, oops, sorry, made a mistake here. This should be a cosine. If you look carefully, you'll see that the sine and the cosine repeat in the complementary. So you can't have them repeat like this. So, huh? Well, because in the particular, you from the sine, you're supposed to have sines and cosines, right? Yeah. But those are already in your complementary. Yeah. So to get around that, what you do is you multiply them here by x in the particular. You understand? Right. You multiply the x term and the cosine term and the sine term by x. Yeah. So every time they repeat, you multiply by x. Now, if the x term repeats, like say you had in the complementary, for example, x sine x, then here you'd multiply by x squared. So you keep exceeding the power by 1 till you get it to a non-repeating format. Yeah, well, you basically, you're bringing it up 1. You understand? Yeah. Yeah, you bring it up 1. One integral, not one derivative. Yeah, right. Yeah, because when you take derivatives, you need to bring it back down to that. Yeah. Yeah. But so this x term is important, and that's why we solve the complementary first, to make sure that the assumed form of the particular does not have a repeating component to it. Because if it does, then we have to account for that, just like we did here, by multiplying each term by x. Right? Plus, now, so this is all coming from the sine. Now we have to take care of the e to the x cosine. So e to the x cosine will have the e to the x cosine x plus the e to the x sine x, both, plus e to the x. Oh, and then we have, of course, random coefficients here, yeah? Like a, b. Since we used a, b for complementary, let's use something different here. So c, d, e, f, e to the x sine x. So the e to the x cosine x will get you e to the x cosine x plus e to the x sine x. Now you look in the complementary and there's no e to the x cosine x. Neither is there e to the x sine x, so you're safe. There's no repetition on this. Okay?
Right.
So your particular solution then will take this form. Okay? Cx sine x plus dx cosine x plus e to the x cosine x plus f e to the x sine. So you do have to solve the homogeneous first to get the complementary to make sure that there's no repetition.
Right.
Question.